my fellow introverts. Stacy here, your programming and test automation expert. If you have been watching us regularly, then you remember that we have a magic method season, and this is another episode. Today we're going to talk about equals operator, not equals operator, is, not is, and also the magic methods of EQ and NE. I will try to show you where you can use them, as well as we will discuss how equality works in Python. In a moment we will start, but before that, please don't forget to like the video, subscribe to our channel, and check the links in the description. There you will find some information about our Discord community and about some things that we discuss in the video. I look like a flight attendant when showing those links, you know.
There are 6 emergency exits on this aircraft. Take a minute to locate the exit close.
So now, let's get on with it. So let's start with the equality in Python. We will discuss equals operator and is operator. If you already know what they do, you can just go ahead and skip to the next section where we will discuss the magic methods. But if you don't know what they do or you're not sure what is the difference between them, you can tune in to this section and we will see how it actually works, as well as you will gain some interview skills, because this is a question that might be asked on the interview. So, first of all, we will need to define two variables. I'm not going to need these guys. We will need to define two variables. A equals 1, let's say, and B equals, let's say, 2. So, let's see what is going to be A equals B. Print A doesn't equal B. And print A is B, print A is not B. Let's run it and see what happens. And we have false because A is 1, B is 2. We have true because A doesn't equal B. We have A is B, which is false, and we have A is not B, which is true. So nothing extraordinary for now. I would just remove these ones because these are just on the contrary of the equal operators. So we will just focus on these two guys. So let's run it again. We have false, false. So now let's see what happens if B also equals 1. Let's run it. True, true. Quite expected, I would say. If we do something like this, it's false and false. So what will happen if we put 1 and 1 as a string here? True, true. These are equal. This one also works the same. So now let's compare two lists. So let's do it this way. Same lists of one element. So let's try to run it. Okay, and here we get different results. So why is this happening? Because we have exactly the same lists. What is the difference between equals and is? In fact, we can take a look at these two guys in another perspective, because everything is an object in Python, and we can get object IDs for both of those lists. So let's do that. To do that, we will do print ID A, print ID B. Let's run it and see what happens. And these are the IDs of our lists, and these are completely different IDs. If this was just a string, we have the same IDs. So what actually happens for mutable types, the ones that can be modified, each time you create a mutable type, it gets another object ID. If you have immutable types, the ones that are read-only, then the IDs for the same values are going to be the same. So this is why this is happening, which gives us an understanding what is operator does, because is operator is actually checking not the values, but it's checking the reference, the ID of this object. This is why we're getting such results in this situation. So let's discuss the EQ and NE magic methods. EQ stands for equals and E stands for not equals. So as you might have guessed, if we define these methods in a class and then we create objects of this class, whenever we compare the objects with something else, the EQ or not EQ and E magic methods are going to be called whenever we use the operator of equality. So equals, equals, or not equals. Where you can use it? Basically, this allows you to define extra logic when you are comparing the objects of this class with something else. I've got a couple of examples for today. The first one is going to be a bit strange, but if you ever worked with JavaScript, you might understand what I'm talking about. So if we talk about JavaScript, we have a structure, well, it's pretty similar to dictionaries, and it's called an object. So objects look like dictionaries in JavaScript. So if you have two objects that have exactly the same values, then they're not going to be equal. Even if you don't use the is operator, well, is operator analog in JavaScript, but you use equals, equals, basically, from JavaScript, they're not going to be equal because these are two different objects. This is how it works in JavaScript. So in Python, when you compare two dictionaries which have the same, exactly the same keys and exactly the same values assigned to those keys, you are going to get a true. So the first example is going to be about making it a bit more strict. So we're going to create a class which is going to inherit from a dictionary, and when comparing the object of this class with another dictionary, even if it looks exactly the same, it's going to give a false. So let's go ahead and implement it. This is going to be the first example today where you can use EQ magic method. So let's call it a JavaScript object, and we will inherit from dictionary. Dictionary. And let's create an init. We'll pass in a value, and we will call a super init. We will pass the value there, and we will do self value equals value, just for the future because we're going to need it in a moment. How we can use it? Well, we can create an object. We will do like this, object, a JS object, and let's pass in a dictionary, A, B. Okay, so we created our JavaScript object. Let's now go ahead and compare it with exactly the same dictionary and see what happens. Print object equals equals. I'm going just to copy it. Okay, let's see what happens. True. Well, it works the Pythonic way. So we have a dictionary AB which equals dictionary AB. I didn't change anything in this class. I just inherited from dictionary, passed the value to the ancestor, and that's it. So basically we have exactly the same behavior. So in order to change it, we have to actually modify how we equal those dictionaries. This is where we're going to add our magic method, def EQ. PyCharm helps me and says that there is going to be other parameter. This is the value to which we are comparing our object. So let's go ahead and do this. We will do return. We need to return it. And we basically return the result of the equality. So in our case, we want to do it this way. We have our value, which is our dictionary. And instead of doing equals equals, which is done by default, we're going to do is other. Just like that. Okay. So let's run it and see what happens now. Okay, false. So we tricked Python, and now this JavaScript object behaves kind of like in JavaScript. Well, kind of course, it's not the same language, but we did something similar. What will happen if we do not equals here? Let's check it out. So I will keep the equals. Let's put some logs here. Equality. And we will do the same thing, but we will not equal. And let's see, not equality. Just like that. Let's run it. And what do we get? False, false. So this is actually happening because we are lacking the not equals operator, and we have to actually also describe it here, because we said that okay, equals is going to be working this way, and not equals, well, it behaves the regular way, the way a dictionary would behave. So let's then create a not equals and e, and do return self value is not other. And now it's going to work. So first example where you can use it is actually to change the way how equals and not equals behave, in order to make something more strict, or just compare some values of particular types. Next example. Let's compare two very similar structures, but by additional trait of those structures. There are multiple examples over the internet. You will find a link in the description where you have some data about a person, and this person might have the same name, the same last name, but the different age. This is something that we use in our documents on daily basis. We have some identity numbers which are based on your name, surname, probably date of birth, maybe some other criteria. So this is a very common example, and of course, if you Google about EQ magic method, you will find a lot of them. I thought that we could take a look at a rather different example when you have different objects in the system, and they're being created over time, and they might look exactly the same, but they're created in different times, so you have to somehow distinguish between them. Probably you have like a storage of objects, and you have to know whether this is the same object or not. So in this case, we could actually attach ourselves to time and see whether this object, which looks exactly the same as the previous one, was created a bit later. So let's define a new class. We will call it let's call it time dependent dictionary class. Time dependent dictionary. We will also inherit it from dictionary, and let's define an init. We will do pretty much the same thing. Self value equals, we need a value here, value, and we will do a super init value. And now we need to add a trait which is going to be unique for every dictionary that we create. Of course, we could use some identifier as well. In our case, we're going to use a time, but we could use an identifier, just a UUID, unique ID, and also create it once we create a new instance, something like that. But we will just do a time here. So let's do it this way. So we will do self-created ads or something like that, at equals, and let's import time. We're going to need it, and we will do time.time just to get the current time in seconds. And now we will create, let's create first dictionary. time dependent dictionary data 1, let's say. Let's create a second one. And we'll copy this guy. Okay, so we have two dictionaries, and we can do a time sleep between them just to be exactly sure that the value of created at is going to be different. Just, just for visibility. Time sleep 1. Again, I want to highlight this. If you have some kind of IDs or something like that, for example, you're using database and you're representing the values from database as objects of a class. A class is a model and you want to create some objects which are the roles in your database, for example, you can use an ID instead of created at value, which we have here. Just for simplicity, we don't have a database today. We could have used the UUID, but let's do it with time. It doesn't matter. So the idea is that we have to have something unique here. Let's print first created at, and we're going to do the same thing with the second created at. And as you can see, these are quite different values. So now we can go ahead and create an EQ magic method and define how are we going to compare things of this type. So first of all, let's create the EQ magic method. Now, first thing, how we're going to proceed here. We need to first of all check whether the actual values of those time-dependent dictionaries are the same. Then the second thing is that we have to check whether the type of the other here is the same. So basically it's a time-dependent dictionary. And the third thing, we are going to actually compare the time when they were created. So 3 things to keep in mind. If any of them is not equal, then, well, these dictionaries are not equal. So let's start with the maybe with the type. So we will do if type other equals a time dependent dictionary, and we will do something here in a moment, but we need to return false if it's not. And then inside of this if, we're going to check the values. If other value equals self value. Again, if they don't equal, then it's a different dictionary, so we return false. And last but not least, we need to check the created at. So we will do return self created at equals other created at. Okay, so now we can go ahead and compare two dictionaries. So let's, instead of printing the created at, we will do print first equals second. False. Yes, because they were created in 2 different times, and basically this is why they are false. But we can create a third dictionary, and we will do it this way, that we will just do third equals first, just like that. So now let's see if first equals third. And here we get a true, because, well, they're basically, of course, they're the same objects, but they have the same created at value, because we just copied them. So you get the idea. So this is very useful when you want to find some criteria, except from, let's say, the actual value, an additional criteria which will allow you to compare 2 of those objects. So pretty useful stuff when you're working with database and you're representing your data in the database as classes. So basically a class is a model, and the object of this class is actually a row in this table. So basically a value of this model. And then you can add an additional check whether they're the same. So if the data is basically the same, but the ID from database is not the same, then these are two different objects. This is how you can do this. Conclusion time. EQ magic method stands for equals, and E magic method stands for not equals. Whenever you want to affect how your objects are being compared with other values, you might want to define these magic methods in your class. Keep in mind that EQ and E magic methods will only work with equals equals or not equals operators. They will not work with is or not is. As far as I know, overriding how is or not is behaves with your object is not permitted in Python. It's not possible. So, well, maybe if you know how to do this, let me know in the comments. But probably I actually agree with this idea because it might make a chaos in your code. So, probably a good idea, definitely. Where you can use the EQ and NE magic methods. First of all, when you define your custom data types, you might want to define how they behave when they're being compared with other data types or the same data types. We did it before. We compared two dictionaries, two custom dictionaries, and we said that these custom dictionaries cannot be equal even if they have exactly the same keys and exactly the same values. So we made them behave kind of like JavaScript objects. You can do something vice versa. You can also make it less strict. For example, if you want to compare 11 as a number and 11 as a string, you can also affect how it works by defining an EQ and an E magic methods, and you might say that they might be equal to each other. This is also possible. The second case is more practical, I would say. Whenever you have some instance, some objects of something, and you want an additional parameter to compare it. Example might be a person representation. You have a name, you have a surname. They might be the same, exactly the same, but these might be two different people. This is why you are making an additional comparison and you're comparing their dates of birth, for example. We did something similar in this video and we compared two same dictionaries, but they had different timestamp of creation. So whatever the reason you might use them, I really hope you will use them on your project. I really hope you liked the video. I wish you a very happy coding and I see you in 1 week.